Hello and welcome to the RX podcast from Fathom World. This is the podcast offering insight into the changing technologies, business models, regulations and attitudes in the maritime and ocean industries. It's for experts and beginners alike, those leading the change and those needing to understand more about what's going on and why. My name's Craig Eason. I'm your host and owner of Fathom World, the news site and subscription newsletter where you can dig into more on the stories that you can find on the RNX podcast. Part of this episode comes from Oslo, Norway. I was there on a recent press tour ahead of the North Shipping exhibition, which takes place in June this year. I'll be there at North Shipping again, hosting and moderating 3 days of the Blue Talks. That's the 12 one-hour chat show style talks where I get to drill down into key topics with groups of experts, digging out some of the latest developments, insights and opinions. I'm going to be talking to people about new fuels, of course, green corridors, carbon capture, the latest in wind propulsion, digital connectivity, autonomous shipping, and whether we can get the crews for the ships of the future. 12 talks, 12 different topics, 3 days. We're back to this episode, and later on we can hear from the founder of a company in Norway that launched an electric whale watching vessel and then saw the pandemic bring tourism to a halt.
Our motto is we're not doing this because it's easy, we're doing it because we thought it would be easy. And that's that's a tale of lessons learned.
But today this company, Brim Explorer, has spun off a technology business because it has seen the need for a technology to help maximise the power from battery to propeller, and it will also soon have 5 vessels in the water. Not bad for co-founders who scrabbled for money at the start to get the first vessel in the water. We'll hear more from Espen Larsen-Hakkebo in a few minutes. Also, we look at the growing order book for dual-fueled vessels, or more specifically the engines for the larger vessels.
So it's really hot. It is, if you could say something about 2023 on two-stroke engine side, it looks like it's going to be the year of methanol engines.
MAN announced last month that it has won yet more orders for methanol diesel dual-fueled engines. So I spoke to Thomas Hansen, head of two-stroke sales at MAN, to ask about the order book. But first, a ship owner. Klaveness Combination Carriers in Oslo. It's not a giant amongst the ship owner groups in the world, but it is notable for the vessel types that it operates. The Oslo-listed company has a fleet of what are known as combination carriers, and before I go on, I think I'll explain what they are, and for anyone who has been in the industry for a while, try and explain what's different between them and the oboes of a few decades ago. Combination carriers are designed to be able to carry both liquid and solid dry bulk cargoes. The idea is that the cargo spaces are designed with hatches for the dry bulk, but with pipework fittings to make them into tanks for the liquid bulk. They are similar in that respect to bulk oil, shortened to oboe. Those vessels were a Norwegian invention to enable ship owners to make the most of the oil markets when they were good and the dry bulk when that was good, on the recognition that those two markets were often kind of counter-cyclical to each other. You know, when one was up, the other was down. These oboes of the 1970s, there were hundreds built. They were expensive though to maintain, and cargo tank cleaning took a long time. I've met some former Shell colleagues that worked on a couple of these vessels that were in the Shell fleet a few decades ago, and I can tell you that they were not well liked by the crews. Anyway, I digress. Klaveness has a more modern fleet, and all of the vessels, or most of them, are on contracts of affreightment and not used for general oil and dry bulk cargoes like the oboes of the 70s. The company's business model is to put these vessels on trades where they carry specific dry cargo one way and specific liquid cargoes the other. Therefore, there's a very short empty ballast leg between the discharge port and the load port, and with regard to the cargo work done per ton CO2 emissions, a bane on most dry and wet bulk vessels, that particular leg is short. Klaveness Combination Carriers recently released its updated sustainability report. There's a growing number of ship owners now publishing sustainability reports, and in it laid out some more details about decarbonisation plans. And in a strategy to be more visible and communicate its business more clearly, KCC has made the unusual decision to launch its own podcast. You'll find it on all the podcast platforms. It's called Outward Bound. You'll also find it listed on Fathom World on a page where I list the growing number of maritime and shipping podcasts. KCC asked me to come into its office in Oslo and be a guest host and to interview their chief executive, Engebret Dahl. They gave me a list of questions, or question ideas. I rewrote them. Then I went into the office and promptly forgot most of them, as Dahl and I had a very lengthy and in-depth discussion about the Klaveness plans for fleet renewal and how they fit into an overall shipping strategy. And I wanted to also ask about how they promoted their decarbonisation efforts with the help of cargo owners. Now, what this is now a clip from the episode, and you'll find the full episode by looking for the Outward Bound podcast. But in the segment, I asked Dahl about the need to order its next new buildings with some fuel solution in mind, only to learn about Dahl's scepticism for the fuel-ready notations that class societies offer ship owners wanting to plan ahead. But the conversation actually kicks off, though, with a question about an emission performance contract or carbon emission adjustment factor that Klaveness has agreed with one of its cargo owners, a mining company. It's a contract where poor performance of ships result in the company losing freight and better than expected performance leading to the cargo owner, a mining company, paying higher freight. Anyway, here's Engebret Dahl, CEO of Klaveness Combination Carriers.
Too few customers today are willing to actually pay for higher freight to reduce emissions. But we have started up, and we are extremely pleased that one of our main customers, South32, the American miner and aluminium company, as part of a long-term contract we have with them for shipment of caustic soda into Australia, have been willing to commit to what we call carbon emission adjustment factor.
Okay.
Which actually means that our emission performance is measured against the baseline. And if we are performing better than the baseline, we get higher freight. If we are performing worse than the baseline, we get lower freight. So actually you get a carbon pricing into the contract and the freight mechanism. And that is and the intention or the requirement is that any money that we raise from that mechanism we will use on investment in our ships, in energy efficiency measures. But I think the important thing is that you actually get, as I said, a price on carbon into the daily operation, the chartering decisions, the scheduling, and that will drive behavior and change.
I'm not going to ask you about the actual amounts, because I know you wouldn't tell me anyway, but you've got a benchmark. Can you tell me at least what you set that benchmark alongside? How do you decide that benchmark? And also whether you've got any discussions about how you strengthen that benchmark. As you find that things get better, you have an agreement where that benchmark may change.
Yeah, so actually in that contract, South32 is a long-term customer of ours that we have been doing shipping for them and their predecessors for 30 years. So we have a long track record of data. So actually what we did, we put a baseline on our actual performance, historical performance over the last years. And then we are assuming a certain percentage improvement per year, assuming that the industry itself, all our competitors, will, with the delivery of new builds, become gradually more efficient. So that is the mechanism that is there. And then, of course, there are, we have a relationship that we will probably develop this mechanism as we go. We used the year to test it out, and know the money is on the table from both sides. I guess the first quarter we will actually have to pay South32 money because we had to do some ballasts, which we didn't intend to do. So it shows that it works. But it maybe we have to, after the trialing, we will have to adjust it as we go ahead in time. The important is the commitment from both sides to make it work.
And just thinking a bit more long term in the future here, before we start talking about the actual, in a way, talking about the fuels, I want to talk about the vessels here, because you're going to have to renew your fleet in due time. I know you've got some new vessels that have come in, but all ship owners have a fleet renewal strategy. So you're going to have to look at fleet renewal or fleet expansion. I know that you have got plans for growth, so it may be expansion as well. But my real question is about the next generation of Klaveness carriers. What sort of decisions are you going to have to make now that will enable whatever you decide with your next buildings to still be viable for you as a company 20 odd years into the future? Because we got all of this uncertainty. So I'm interested to find out what you as a vessel operator and owner are going through right now to make sure that whatever you put on the water, maybe in 5 years' time or 8 years' time, is still going to be valid, 30 years into the future.
And of course, it is a difficult choice. Of course, ideally with the idealism that we have and the targets we have, we'd have loved to create the base for us to make the investments today that actually would make the ship zero emission capable at delivery. Given uncertainty on which type of fuel, given which will be the ideal fuel going forward for the industry, the uncertainties regarding the technicalities. We still don't have, for instance, a class regulation for use of ammonia on ships. The engines are not ready. So at where we are today, and with the customer support we see, we probably are not able to make the choice of making the ships fully capable of burning ammonia or methanol or even LNG.
But why not? I'm seeing order books for methanol, increasing. I can list about 80 vessels, and I spoke to MAN, the engine maker, who said, well, actually, we're having discussions with another 120. So we could, if that goes well, we could see 200 methanol-fueled vessels, or dual-fueled, let's be honest, they're dual-fueled vessels in the order book. I mean, it's probably not going to be that, but it could be up to that. But you're telling me that's not for you.
We're not saying it's not for us, but we're saying that where we are at the stage, we believe that it may be better to make the necessary preparations to create the flexibility for these ships to do a later retrofit, while we in parallel try to work to get the things in order to take the decision. But of course, if you look through the list of the people that has, the companies that have contracted, you see a high proportion of them are the big container liners, which also have a different customer setup with people like IKEA or, that actually are willing to pay for lower carbon freight.
Well, that goes back to the discussion about your cargo owners.
Yeah. And again, and these are companies that are so immensely huge. They are willing to invest in suppliers of green methanol. They are willing to give, 10 years, what we call off-take agreements for the fuel. We as a small company, where we cannot do that, meaning that you are right, the engines are there. So basically the technical risk for installation of methanol on ships are low. So I think the big uncertainty is, when can you expect to get the green methanol to your ships? And as we see now, there's no outlook of when that can happen. So that means that you put on board, was it $6-7 million or whatever the cost would be to make them methanol capable from delivery, without any outlook for when that fuel can be ready and be used.
So your vessels, whenever you're going to order, more likely that they will be methanol ready, potentially even possibly something of ammonia ready, not actually with the engines, but they'll have some of the pipe work ready. You will have designed where for ammonia the fuel tank may go.
Yeah. Of course, we're not that concerned about the class notation, because, there are many class notations for so-called ready ships. So rather, we don't want to talk about this class notation, because, I won't say it's a scam, but at least it's something that doesn't create credibility around the process. So what we're going to do is to make everything what we can do at the moment ready, which make it easier to make the next step, which means that the superstructure of the ship has to be built in a different way in order to have space for the fuel tanks behind and after the ship. You need to have the strength in the deck for the fuel tanks, which are pretty heavy. You need to make the stability and the strength of the ships to adapt to it. You maybe have a space for this fuel preparation room for these type of fuels, the piping, making tanks ready for methanol, and the existing fuel tanks. There's something with the coating, something with the cofferdams around it. So there are a number of things that you will do that will cost you a number of $1 million, but which will make it so much easier and both faster and less expensive to take the next step. And the thing is, when we talk to engine manufacturers, they're saying that whether you get a dual fuel engine delivered today, capable, whether you convert it to the latest stage, has no impact on the engine's performance.
Okay, so you can order the latest MAN or Wärtsilä or WinGD vessel, put it into your ship and convert it at a later date once you've solved your fuel conundrum.
Yeah.
And you'll still get the same efficiency as if you put the engine.
You do. But again, don't misunderstand me, Craig. I mean, we would have loved to do it. But again, if you do what you call evaluation based on facts and based on where we are, on regulations, customer support, fuel availability, technical issues, and outstanding issues, I think, from our side, where we are today, that is probably the most likely way we're going to go forward.
Engebret Dahl, CEO of the shipowner and operator Klaveness Combination Carriers, on his thoughts on fuel readiness for the company's next look at the new building market. Now, these Klaveness vessels will likely have an engine from one of the major engine makers in whatever country the ships are being built. Quite likely China and Japan, which were where the Klaveness new buildings came from in 2021, but possibly, South Korea or somewhere else like that. A couple of weeks ago, MAN, the engine maker, announced a new tranche of orders for methanol dual-fueled two-stroke engines. The order books are rising, and I wanted to ask MAN about the licensees who handle the orders for new engine types. You may not know it, but MAN does not actually build its own two-stroke engines. The company has engine makers around the world who have the licenses to build the engines based on the MAN designs. This includes the growing range of dual-fuel engines. So I spoke to Thomas Hansen, head of two-stroke sales at MAN, about the trend.
We keep a portfolio of all the ongoing projects where we know a ship owner has been in talks with a shipyard and is trying to buy a new ship. And we, of course, keep record of all these projects. And out of these, 33% right now are for methanol as a fuel. So it has even surpassed LNG right now. And so it's really hot. It is, if you could say something about 2023 on two-stroke engine side, it looks like it's going to be the year of methanol engines.
What can you tell me about where these orders are being placed and what kind of vessels we are looking at? A lot of people will know about the large container operators, but is it largely the container operators and their large vessels? What's the size of the engines? What's their end use? What kind of vessels?
The initial order uptake for methanol engines back 5 years ago was for tankers, and that still goes on at a steady pace. But the new thing here is the large order uptake for container ships primarily, and that's primarily has been for large container ships, 15,000, 16,000, 13,000 TEU, and also we saw the order for Hyundai Merchant Marine for 9,000 TEU. So that is for businesses which are near to the consumer, where the operator has a clear business plan on how to charge a premium when operating on a green fuel. But we also see interest from bulk carrier segment and from tanker segment, apart from methanol tankers. So it looks a little bit like it's all over right now. It's all over the shipping segment, but dominated by container ships.
One of the things when I look at these when I look at the vessels, when I look at the order book, it's two-stroke engines. Let's just be clear here. We're largely talking about two-stroke engines, and they're being built in Korea, South Korea, China, Japan,
yes,
potentially through your licensees. And
Correct.
The order book is quite significant. Is there going to be any kind of challenge in actually meeting that demand? I know when there was a huge rush on the order book a few years ago, well, a decade ago, when there were a lot of orders, the yard suddenly found it quite difficult to meet demand.
Yeah.
What's the risk of there being a demand shortage, of a lag in delivery of engines?
Of engines in general, there is, of course, you could say there is a relationship between the worldwide shipyard capacity for large merchant ships and then for the worldwide engine production capacity. So these things more or less fits. And we also did a big analysis last year because we were also afraid. We wanted to know for a fact, is there enough engine building capacity to cater for the shipyard's needs? And we found that it is okay, and it just adds up because, as you may know, shipyards are more or less full. Right now, if you order a ship today, you will get it maybe in 26 or 27. And there are engines, no problem to get engines so far out in the future. The order books at the engine builders, they are in generally full for 23 already. They may have a little bit of capacity left, but 23 is booked up. And 24 is well on the way, but maybe only half full. So it means that there is plenty of capacity available with the ship lead times. And there's really not so much difference if you want a fuel oil engine or a methanol engine in the general production capacity. Of course, the license builders, they need to do some further investments if they want to have production facilities to do methanol-powered engines. But that comes, you could say, naturally by demand. So no, we don't see any bottlenecks.
I see a lot of talk about having a future shipping industry that is fit for the future, that has a versatility, that they don't get locked into a dead end of, a fuel type that isn't for the future. And we can go into a lot of discussions about what those fuels are, but I'm not going to do that now. My question, though, is around the versatility and the capability of an engine once it's been ordered, such as a methanol or ammonia dual fuel engine, to be retrofitted, so methanol to ammonia or ammonia to methanol. What's the pros and cons of having an engine that is multi-fuel compared to just dual fuel, and what are the opportunities or conditions for actually retrofitting if you feel that that is what you want to do with a ship?
Yeah, so basically it's a fundamental part of our design that the engines have to be retrofittable. So we take that into account whenever designing a new engine. So they are all, with one exception, which is the Otto-cycle LNG engine for LNG carriers, the MEGA engine. All the other engine types we have, they are retrofittable. So on the design basis, we are good. But then comes to pros and cons. The thing is that if you want to make an engine which is easily adaptable into any kind of fuel, then you would need to compromise on efficiency. So the way you have to shift between fuels with engines of our design is you need to change the fuel injection equipment for that extra fuel. So if the engine from the outset was built for using fuel oil and, let's say, methanol, and then you later wanted to retrofit it into using ammonia instead of methanol, then you would need to fit a new fuel system, fuel supply system, and fuel injection system for ammonia to the engine. And basically, because you would want to have the highest possible efficiency, because the fuel is expensive and efficiency is king when it comes to reducing CO2 emissions, right?
That was Thomas Hansen from Engine Maker Man on how ship owners can build in flexibility to new building designs, and I know full well I'll be coming back to this story again in future Aronnax episodes. Now, this is the Aeronax podcast from Fathom World, and a reminder to seek out our stories that you hear about on the podcast on fathom.world and to subscribe to the newsletter that I try to send out once a fortnight. Now, back to Oslo and the breeze. Anyone who goes to Norway knows that the country is going electric. The number of small battery-powered vessels in the country is kind of impressive, and one of the companies that started in 2018 is Brim Explorer. In 2019, two entrepreneurs that started the company, Espen Larsen-Hakkebo and Agnes Arnedotter, a Norwegian and Icelandic, won Norrshipping's Young Entrepreneur Award. But then a year later, the pandemic struck, tourism died off, plans changed. Things looked difficult, but despite the challenges, this company will soon have 5 vessels in the water, some pure electric, some hybrid electric, and a spin-off technology company, Brim Tech. But now, while whale watching with silent vessels is a bonus, particularly for the cetaceans, and the company has made the most of its position by offering silent boat tours, with one of its boats being in the Oslo fjord, I wanted to go and meet up with them and talk to them about the spin-off. The spin-off came about because the two entrepreneurs and their team realised that to build the boats that they wanted, they needed to rethink the power relationship between motor and propeller. So while I was in Oslo, I went on board Breeze, the company's vessel in the fjord, and met with Espen Larsen-Hakkebo to talk me through the decision to create the spin-off and to also explain how the business has grown so quickly.
Our motto is we're not doing this because it's easy, we're doing it because we thought it would be easy. And that's that's a tale of lessons learned. Now, one of the key lessons that we learned is that when you're electrifying a ship, you have to start from scratch. You have to throw all convictions out of the window and rethink how you design the ship from the hull and onwards. One of our lessons, building 2 hybrid electric ships first, we saw that there is a lot of energy efficiency gains to be found in optimizing your driveline by basically not thinking a diesel engine, a combustion engine, with all the limitations that comes with that, and rather seeing how can you design the optimal propeller for a hull, and then finding the optimal motor for that propeller. Instead of when you build a conventional vessel, you're basically looking at how much energy do I need to run this ship at a given speed, and then you're basically designing the propeller with the limitations of the RPM, the speed of the diesel motor. And the speed of a diesel motor is a lot higher than what the optimal speed of a propeller is, meaning that there is always a compromise. When we're going electric, you don't need to compromise because we have unlimited torque available in our newly developed direct drive motors.
So you've split out a separate kind of company from this lesson that you learned, and looking at how you can take this specific technology, applying battery power directly on a drive to the propeller. How are you looking at evolving this? What would you say are sort of the key elements of this? Because I gathered it wasn't easy to find partners, engineering companies, technology companies, to actually go on that journey with you.
No, that's right. When we started looking for the optimal motor, we couldn't find it. They were either too heavy or not powerful enough. But we knew that it should be possible. So it was basically a hunt for the perfect motor. We didn't find it, but we found a specialist in electromagnetism and high torque motor production, not for maritime use, but by teaming up with DNV, we were able to co-design with this company a motor that basically has unlimited torque in our range. We're talking from 10,000 to 50,000 Newton at a very low RPM.
What does that mean? Most people who are listening probably don't know what a Newton is in this context.
Well, it's about the torque. So basically, to run a propeller around, you need the torque to make it go round. So you can and the amount of kilowatts you get out of the end of the propeller is basically a function of the torque and the RPM.
Okay.
So if you want to have the same kilowatt output at a very low RPM, you have to have more torque.
Are you going to look at how this technology can be applied in other vessel types? What's your hope with this? The reason I'm asking is we see a lot of discussion about electrification in the shipping industry, and it's my impression that at the moment batteries tend to be used on smaller vessels, like the Brim Explorer vessels, not on so much in commercial. But I'm seeing some belief that the technology for batteries, there's a lot more power density in the batteries now. They're more economical to run. Do you see a future where there's going to be a lot more demand for your kind of direct drive batteries, I guess?
It's a direct drive motor. We still have a cable and a converter to kind of convert the energy. But what we've done is that we've basically gone back to simpler. Gone back in time. If you're looking at an old steamer, they had a direct drive motor because the motors on steamer were very slow moving and they would have a large propeller. So we're basically going a step back in terms of applying new technology to old conventions. The potential is there for every efficient propulsion line. If you want to make your propulsion line more efficient, you need to take away the mechanical losses that you have in a gear. You need to be able to optimize your propeller and have a more efficient propeller. And in cruise ships or bigger ships, they already have a direct drive. Some of them already have a direct drive, and some of them even have a direct drive electric motor. What we found is that this is also possible for smaller vessels by utilizing our motors. When it comes to other vessel types, what we've identified as our core market would be passenger vessels of sizes from 10 to 50 meters, high-speed crafts of the same size, but we're also actually having now a request for a bulk carrier of 70 meters to carry concrete. So it's basically very versatile because what you have is a very powerful small motor that can propel a ship.
Let's go back to the company. The company's about 5 years old now, and you've split off this more technology-focused part of the business from the tourism aspect of it. But during those 5 years, we've had the lockdowns, we've had the pandemic, we've had a lot of basically no tourism. How have you managed to keep the business going so successfully? And actually, for 5 years, you've got 5 vessels. It's almost like every year you've been, on average, been able to build up the number of ships you've got. So you've done remarkably well as a kind of startup vessel owner.
I think we've been very fortunate in terms that we hit a nerve when we launched our first ship. We went right into operation from the yard, right into operation, and had a very successful 5 months of operation where we proved our concept before the lockdown. Then during the lockdown, we got our second ship in May. That was, of course, a difficult period, but it also gave us a lot of opportunities to test new things. We basically moved our ships, and that's the benefit of having a ship rather than building a hotel. You can move to where there are people. So we basically put one ship in the one destination that Norwegians went on holiday in 2020, which was Lofoten Island. And then we put the other vessel in Oslo, which is the capital and also the most populated area. So when we were allowed to operate, we operated, and that way we kept our crew, we kept our company going, and of course we had a small loss in 2020, but we built that quite quickly up again in 2021, and 2022 was a success. And by just seeking the opportunities where they are, being mobile and being flexible, we managed to get through that period as well.
So you've got 3 vessels in operation now, one in Oslo, one in Lofoten, and a third one in Svalbard, up in the very top.
Yeah. Our third vessel is actually at the moment in Tromsø. It's getting ready to go to Svalbard now when the ice disappears, and we'll go up mid-April, start operations 1st of May in Svalbard. Yeah.
And the two vessels that you are currently, well, one's going to be delivered in the summer this year and another one next year. So what's the plan? Are they also hybrid? Are they electric?
They are hybrid ships with fully electric drive lines, but they have then range extenders that can allow you to operate for longer distances without short charging. Yeah.
And one of them is going to be going up to Svalbard.
Yes, one will replace the ship that we have already in Svalbard, because what we're seeing is that our first generation that we built 4 years ago, electric or hybrid electric ship is spending more or using more fuel than we like. So we're putting that into an operation where it doesn't demand so much diesel, and then we're putting our most efficient vessel in operation in Svalbard.
And
that's because we travel very long distances in these places.
To go up to Svalbard and stay in Svalbard.
Yeah, just to staying in Svalbard and operating there. Yeah.
And finally, you've got this relationship with Norled. Now you've got a partnership with Norled.
That's true. We're trying out a new form of partnership with the biggest fast ferry operator in Norway called Norled, where they've won a public tender that requires them to have a spare vessel in case of technical downtime or when they have planned maintenance to sustain the operation throughout the year. Now, in most tenders, that would be a vessel that would lie quayside for the whole year and only be used for those few days. Now we've then teamed up with Norled and we've built a vessel together where we have designed it. We're using our technology, our design, and operating as a 100% fully electric vessel for 90% of the year. And for the few days that we need to operate in the public tender, we have range extenders that can take us up to 30 knots speed over a longer period of time.
What sort of differences would that be in the sort of operational profile? When it's normally your vessel, it'll be operating at a slower speed and you'll be getting more operational time with the batteries.
Correct.
But when you've got this range extender, you'll be operating at a much more public sector speed. Yeah,
basically it's as a public tender going between remote islands in the north of Norway. There are long distances to be covered, and we need to be able to sustain the route of the public tender. So then we have to go fast. But for the remaining part of the year, we're a tourism company. We can choose routes that are not as demanding, and we don't have to travel those long distances to show our tourists and our guests the most interesting places around where we're going.
When you started Brim back in 2018, how did you secure the financing to be able to do this, to make this decision, I'm just going to become a vessel owner? It's not something you can just decide over a cup of coffee one day with a couple of co-founders. It takes a lot of investment and it takes a lot of planning. How did you secure the interest of the backing that you needed for this?
Well, I'm pretty sure it wasn't over a cup of coffee. I'm more inclined to say it was over a couple of beers. But no, we were operating. We were renting ships and operating whale watching with wooden ships. And looking at our operations and looking at the competition, we saw that we can do this a lot better. We can do this a lot better if we can design our own ship and make it more sustainable and make it better suited for the operation. So that was our starting point. And then obviously neither me nor my co-founder coming from wealthy families, we had to find the resources to make this happen. So we reached out to a lot of friends and family and what do you call it? Friends, families, and fools. And we raised about 1.5 million euros, which was enough to get us building the first vessel and get a proof of concept. We also got some public funding. We got a loan, a risk loan of 1 million euros from the government. And we got some support from the environmental fund to make a hybrid electric vessel. And then the rest was the bank. Yeah. And then going forward, we got a contract for a second vessel and raised money through basically showing to a proven concept and the contract.
So where's the company going to go to now? You've got, 5 vessels soon under your belt in ownership, and you've got the technology division now. Is the focus going to be on the technology or on the tourism?
Well, basically the two co-founders, we haven't split up, but we've taken control of each part of the company. So I'm leading the tech division, and my co-founder is leading the tourism division. There is a lot of overlap, obviously, but we're then building 2 separate teams, and to be able to focus on both operations, so to say. Yeah.
Good. Espen, thank you very much for the time. I appreciate it.
Thank you very much, and thank you for coming on board.
Espen Larsen-Hakkebo from Brim Explorer talking to me on Breeze, one of the company's electric vessels, about new technology needs and the demands they see for electric-powered vessels. So that's it for this episode. This is now the 67th Aeronax episode. Let's see if I can get to 100 by the end of the year. So please spread the word, like it, and especially share it so we can spread the word about the changes of the shipping and maritime space. Help us find more listeners and subscribers to the Fathom World newsletter. And feel free to get in touch. Any ideas welcome. Until the next time, I'm Craig Eason. Goodbye.